Have you ever wondered how entire skyscrapers rise into the sky? How giant steel beams, massive concrete walls, and thousands of tons of construction material are lifted hundreds of feet above the ground with unbelievable precision? Look closely at any major city skyline and you'll see one machine towering above everything else: the tower crane. These giant machines are the silent monsters of modern construction. They can lift loads heavier than dozens of cars, rotate high above crowded cities, survive powerful winds, and help build some of the tallest structures on Earth. But here's the crazy part. Despite their enormous size, tower cranes operate using an incredibly delicate balance of physics, engineering, and precision control. One small mistake, one overload, or one strong imbalance could turn a multi-million-dollar machine into a deadly disaster. So how do tower cranes actually work? How are they assembled? How do they climb taller as buildings rise? And how do operators sitting hundreds of feet in the air control these mechanical giants with such insane accuracy? In this video, we're going deep inside the world of tower cranes, the powerful machines that literally build our cities from the ground up. Tower cranes are modern lifting machines designed to move extremely heavy materials both vertically and horizontally across construction sites. Unlike mobile cranes that move around on wheels, tower cranes stay fixed in one position. They are anchored firmly into the ground using massive concrete foundations, allowing them to rise to incredible heights while remaining stable. These cranes are specially built for high-rise construction. They can lift heavy loads, rotate in a full circle, and place materials with amazing precision. Without tower cranes, building modern skyscrapers would be almost impossible. Some of the world's largest tower cranes can lift over 100 tons. That's heavier than multiple trucks combined. And yet, these giant machines can still move materials smoothly and accurately high above crowded cities. The history of cranes goes back thousands of years. Ancient civilizations used simple lifting systems powered by people and animals. The Greeks and Romans created early crane designs using pulleys and wooden wheels to help build temples and monuments. But the modern tower crane only appeared during the 20th century. As cities became taller, engineers needed better machines capable of building upward instead of outward. After World War II, construction exploded across the world, and tower cranes quickly became essential for large projects. Today, tower cranes are symbols of growth and development. Whenever you see cranes rising above a skyline, it usually means the city itself is expanding. To understand how tower cranes work, we need to understand their main parts. Everything starts with the foundation. Tower cranes are attached to huge concrete bases underground. These foundations are extremely heavy because the crane must remain balanced while lifting massive loads high in the air. Attached to the base is the mast. The mast is the tall vertical tower section that gives the crane its height. It is made from steel lattice sections bolted together. This triangular steel design keeps the structure both strong and lightweight. At the top of the mast sits the slewing unit. This is the rotating system that allows the crane to spin in a full circle. The slewing unit contains motors, gears, and bearings that control the crane's movement. Connected to the slewing unit is the jib. The jib is the long horizontal arm that carries loads across the construction site. A trolley moves back and forth along the jib to position materials exactly where workers need them. Behind the crane sits the counter jib. This shorter arm holds heavy counterweights made from concrete or steel. These counterweights balance the crane and prevent it from tipping forward when lifting heavy materials. The crane also uses a hoist system made from steel cables, pulleys, drums, and electric motors. This system lifts and lowers loads safely through the air. Near the top of the crane is the operator cabin. This is where the crane operator controls the entire machine. Operators often work hundreds of feet above the ground with an incredible view of the construction site. Inside the cabin are joysticks, monitors, communication systems, and safety controls. Operating a tower crane requires serious skill, concentration, and training because even a small mistake can become dangerous. Tower cranes operate using the principles of balance and physics. When a crane lifts a load, gravity pulls downward. The crane must balance at force using counterweights on the opposite side. Think of it like a seesaw. If one side becomes too heavy, the entire structure tips over. The farther a load moves away from the center of the crane, the more pressure and force it creates. This force is called torque. Even a smaller load can become dangerous if it moves too far outward. That's why tower cranes follow strict lifting limits. Modern cranes use computer systems that constantly monitor weight, balance, and movement to prevent overloads. If the crane detects unsafe conditions, warning alarms activate immediately. Some cranes can even stop operating automatically to prevent accidents. There are several different types of tower cranes used around the world. The most common is the hammerhead crane. This traditional design uses a horizontal jib and trolley system. Hammerhead cranes are widely used for skyscraper construction because they provide excellent stability and lifting power. Another popular design is the loofing jib crane. Unlike hammerhead cranes, the jib on a loofing crane can move upward and downward. This allows the crane to work safely in crowded urban areas where nearby buildings limit space. There are also self-erecting cranes. These smaller cranes can assemble themselves automatically and are commonly used for smaller buildings and residential projects. One of the most fascinating designs is the climbing crane. As buildings rise taller, climbing cranes literally grow with the structure. Hydraulic systems lift the crane upwards so workers can insert new mast sections underneath. This process allows cranes to reach incredible heights during skyscraper construction. One of the most amazing things about tower cranes is how they are assembled. Since tower cranes are too large to transport fully built, they arrive in separate pieces. The process begins with the concrete foundation. Once the foundation becomes strong enough, mobile cranes bring in the first mast sections. Workers bolt these steel sections together one by one. As the structure grows taller, more sections are added. Eventually, the slewing unit, jib, counterweights, and operator cabin are installed. After all systems are connected and tested, the crane becomes fully operational. But here's the incredible part. Once a tower crane reaches a certain height, it can help build itself. Using hydraulic climbing systems, the crane lifts its own structure upward, while workers insert additional mast sections beneath it. This engineering process allows cranes to climb alongside the building as construction continues. Tower crane operators have one of the toughest jobs in construction. They work high above the ground for long hours while controlling extremely heavy loads with precise movements. Operators must stay constantly focused because they are responsible for the safety of everyone below. Communication is extremely important on construction sites. Operators work closely with signalers, rigging crews, and supervisors using radios and hand signals. Weather also creates major challenges. Strong winds are especially dangerous because tower cranes stand so high above the ground. Heavy winds can cause loads to swing uncontrollably through the air. If weather conditions become unsafe, crane operations stop immediately. Modern tower cranes include advanced safety systems designed to reduce risk and prevent accidents. Load monitoring systems track the crane's balance, lifting force, and weight limits in real time. Wind sensors continuously measure wind speed at the top of the crane. Emergency braking systems stop uncontrolled movement if mechanical problems occur. Large construction sites often use anti-collision systems that prevent cranes from crashing into each other. These safety technologies help operators work more safely in difficult environments. Tower cranes face many extreme challenges every day. They operate in rain, snow, heat, lightning, and powerful winds. In crowded cities, cranes often work only feet away from buildings, roads, and power lines. Precision becomes absolutely critical. Some of the world's largest tower cranes are truly enormous. Mega construction projects use cranes capable of lifting over 100 tons and reaching heights above 800 feet. These giant machines are used for super skyscrapers, bridges, industrial plants, and massive infrastructure projects. Tower cranes are more than just a piece of construction equipment. They are symbols of human ambition and engineering. Without them, modern skylines would not exist. They make it possible for humanity to build taller, faster, and more efficiently than ever before. As technology continues evolving, future tower cranes may include artificial intelligence, automation, remote operation, and advanced robotics. But even with all these future innovations, the basic principles behind tower cranes remain the same. Balance, strength, precision, control. The next time you see a tower crane towering above a construction site, remember this: you're not just looking at a machine. You're looking at one of humanity's greatest engineering inventions, a giant mechanical system helping build the future, one lift at a time.